We are now going to discuss some typical phenomena for satellite communication system. The common people may not be able to understand those things, but as an engineer, you must understand some this type of phenomena occurring in satellite communication system. The first of all, uh, we will understand the solar eclipse. If you consider the situation that sun is here, earth is here, satellite is rotating in this orbit, right? Now when position of the satellite is in between sun and earth, we have a phenomena called sun transit outage. We will discuss it later on. But when the satellite is right here, that means sun is here, earth is here, and then we have the satellite. Then the satellite will be inside earth's shadow region, right? Like this one. So it will start to enter into the shadow region at point A. It is fully inside the shadow region at point S, and it will start to move out from the shadow region at point C. So between A and C, the satellite is within the shadow region of the Earth. So what happens? During that period of time, satellite will not be able to get the sunlight, right? Because it is in the shadow region. And under that condition, the solar panel that is used to generate the electricity inside the satellite will not work, right? So that is what is called the solar eclipse. Now, what is the duration of such solar eclipse? That is the first question. And second question is, every time or every day do we have solar eclipse? So first let us understand these or solve these two questions. To understand this, first of all, we have to understand that the equatorial plane of Earth, equatorial plane of Earth uh, is not in the plane of rotation of Earth around Sun, right? It is tilted at an angle of nearly 23 degree and half, 23 point half and 0.5 degree, right? So, uh, and the satellite is revolving. We are considering the geostationary satellite, and satellite is revolving, actually revolving in the equatorial plane of the Earth, right? So when the satellite is in this condition, position A, okay, position A, because it is tilted, the orbital plane is tilted with the plane of plane in which the Earth is moving around the Sun. So under that condition, there is no place where the satellite can enter in the shadow region of Earth. So when the Earth's position is somewhere here, the satellite will not be in eclipse. Okay, so when the eclipse will appear? That is the question. When the eclipse will appear? Eclipse will appear when we have equinoxes. We have two equinoxes. One is the spring equinox and another is autumn equinox. Okay, so under these two conditions, when we have spring equinox, then the satellite will be inside the shadow region of Earth. Similarly, when we have autumn equinox, the satellite will be in the shadow region of Earth. Right. Now, equinoxes like 23rd March or 22nd March, it is at the peak condition. Okay, it is at the peak condition. Also, during September, nearly 23rd September, we have the equinox, so it is at the peak condition. Eclipse is at the peak condition. So actual eclipse will start 23 days before the equinox and it will continue 23 days after equinoxes. Then the eclipse will stop. Right. Now, since Earth is an extended body and Sun is also an extended body, so the shadow region, there are two kind of shadow region. One is the half shadow or partial shadow, another is the complete shadow. Okay, so as you can see, starting from uh, nearly 1st March, the satellite will begin to enter inside the shadow region of Earth and it will continue up to say 13th of uh, April. Okay, but from 1st March, the amount of time for which the satellite is inside the shadow region is really small, just for few minutes. But for 2nd March, 3rd March, the amount of time will increase. Right. So at nearly 11th of March, the eclipse time is almost 1 hour, just 55 minutes or 5 minutes smaller than 1 hour. But at 22nd of March or 23rd of March, it becomes maximum and it is nearly 1 hour and 7 minutes, right? Under full shadow condition. Same thing is repeated for the September. Okay. So starting from 1st March up to nearly 13th of April, we have eclipse, right? We have eclipse and near this region we have another eclipse. Now, where the satellite longitude is east of the Earth station, the satellite enters eclipse during daylight hours for the Earth station. And this can be undesirable if the satellite has to operate on reduced battery power. Where the satellite longitude is west of the Earth station, eclipse does not occur until the Earth station is in darkness or early morning when usage is likely to be low. Thus, satellite longitudes which are west rather than east, the Earth station are more desirable. Most of the time, uh, for a particular satellite, number of Earth stations are actually used. So one of the reason is this. So far we discussed that reveals that during eclipse we have cutoff of power supply because solar energy will not incident on the solar panel, so solar panel will not work, right? Suppose the energy requirement for that particular satellite is say 10 kilowatt, which should be supplied by the solar panel, and solar panel is not working because the, the satellite is inside the shadow region, right? So what next? What should we do under that particular condition? So let us see what measures we can take. During full eclipse, a satellite receives no power from its solar array and it must operate entirely from its batteries. Batteries are designed to operate with a maximum depth of discharge. If the battery is discharged below its maximum depth of discharge, the battery may not recover to full operational capacity once recharged. Those are the problems of any battery, any rechargeable battery. We are facing this particular problem. The depth of discharge therefore sets the power drain limit during eclipse operations. Nickel hydrogen batteries, along the mainstay of communication satellites, can operate at about 70% depth of discharge and recover fully once recharged. Ground controllers perform battery conditioning routines prior to eclipse operation to ensure the best battery performance during the eclipse. And actually this is very much important because if battery fails during the eclipse, the essential portion of the satellite may fail. So that is a disastrous condition and we don't want it to happen. The routines consist of deliberately discharging the batteries until they are very close to their maximum depth of discharge and then fully recharging the batteries just before eclipse season begins. So as conclusion, we can say the eclipse season is a design challenge for spacecraft builders. Not only is the main power source withdrawn, that means the sun, but also the rapidly with which the satellite enters and exits the shadow can cause extreme changes in both power and heating effects over relatively short periods. So that is another adverse effect that we usually don't consider it, but it is a very serious problem because when the sun is there, uh, the front side of the satellite uh, temperature of that portion may be around more than 100 degrees centigrade, but if sun is not there, then it will come down to minus 100 degrees centigrade or even lesser. So that extreme changes takes place at a very fast rate, right? Once it is inside the shadow region, suddenly the temperature goes from high value to very low value. So that will create lots of problem. Just like a common light bulb is more likely to fail when the current is switched on, as opposed to which it is under steady state conditions, satellites can suffer many of their components failure under sudden stress situations. Eclipse periods are therefore monitored carefully by ground controllers, as this is as when most of the equipment failure are likely to occur, because as you know that the battery backup is not sufficient to operate all the components. So during eclipse it happens that some of the components are switched off. So once eclipse is over, after several minutes, those components are turned on, and during that turning on the failure occurs. So that's the problem.